Hello and welcome in another Python tutorial. In this one I'm going to cover Matplotlib, and for those of you who have never heard of this library, well, this is probably the library that is most widely used when it comes to creating all kinds of graphs and charts with Python. And I'm going to cover as much content as I can to help you get started with it. And in the description, of course, I'm going to add a timeline of the video in case you only want to learn how to create line charts or maybe histograms or scatterplot and you just don't feel like going through the entire video. So let's get started. Let's start with creating a simple line chart, and then we're going to build on top of it and see what we can modify and add to it. Before we start, of course, we need to have some data to work with, and line chart is usually used to analyze data over time, such as stock prices or sales over a given year or per month. So what I'm going to do is I'm going to create X and Y, which would be our fake data that we're going to use for this example. So again, on the x-axis, we would have time in terms of days, months, or years. And on our y, we have data such as stock price or maybe sales and so on. And in our example, we're going to use sales for a unit that we're just going to create. And the time would be day of the week. So on our x-axis, we would have 1, 2, 3, 4, 5, 6, and 7, so Monday to Sunday. And let's create 7 random numbers as sales. So how do we plot once we have the data? That's fairly simple, but before that we need to import matplotlib.pyplot. So matplotlib.pyplot, we're going to import it as plt. So when we use plt, basically we're using this matplotlib.pyplot, plt.plot x, y, and then we want to show it. And simple as that, in a few lines of code, we have our chart. Now, this is fairly simple, but there's a lot more that we can add to this. We don't have a title yet. We don't know what this line represents. We don't know what this 1, 2, 3, 4, 5, 6, 7 is. Maybe we want to change this to start from 0 or from 10, or not go to 180 but to 200. So we're going to see how we can change all that. First, what I would advise you to do is when you have a variable, make sure that this is descriptive. So X is not really saying a lot. Yes, we do have the comment, but maybe we can have here, for example, days, and Y would be sales, and let's have sales underscore 1. So that would be the company 1, sales of company 1, because later on we can add one more line chart of company 2. So for now I'm going to leave that empty, but we're going to populate that later on. So sales 2 would be equal to an empty list for now. But now that we've changed the variable name up here, we need to also align it with the plt.plot. So let's continue by seeing how we can add a simple title to our plot. And for that reason, we are going to use plt.title, which would be sales per day. And we can also add, for example, in euros. So in just one line, we have our title, but maybe we would want to have this in euros appearing on a separate line. So in order to do that, what we need to do is we just need to create a new line as part of our string, and it would just show as on a separate line. If you want to have more space, if you want multiple lines, then you can just include one more. Of course, it's up to you to see what looks best. But for now, I'm going to stick with this. And we can also adjust the font size of the title. I'm going to set it to 15 and the color to be equal to blue. So in this one line, we have the title, we have the font size and the color. And if we want to adjust any of that, then this is the line that we're looking for. And simple as that, we have our blue title with font size of 15. Now there's one thing that can go wrong here is if you choose a font size that's larger and doesn't fit on your figure size, that it's not really readable. Of course, there are a few ways to fix this, but one way is to change the figure size. So plt.figure, fig size, it takes a few arguments. The first one is a tuple, which would be the ratio of x to y. So I'm going to set that 6 to 5, and then it's the dpi or dots per inch, and I'm going to set that to 150, and I think the default is 80 if I'm not wrong, but anyway. So I'm going to print this, and as you can see, our figure has increased significantly compared to the default, and we can also read the title much better than before. And I'm going to stick with this one for the rest of the tutorial because, well, it's quite easy to see what's on it. Now let's add the X and Y labels, and the way we do that is, well, quite similar to plt.title. So the way we added the title, except now it would be plt.x label, and our X label is day of the week. The font size, let's set it to 15, so a bit smaller compared to the title, and the color, we're going to be consistent and use blue. So same goes for the Y label, which shows the sales. Font size, we're going to stick with 15, and color equals blue. And with only a few lines of code, now our line chart has some additional information that makes it much more easier for the user to understand what is displayed. What we can still improve quite a bit is the line itself. So if we want, for example, to make the line a bit more wider, or maybe we want to make it a different color, well, everything that we want to adjust line related is in this plt.plotline. So let's add some comments. So this would be line related, and this is quite clear, but let's include that title related. We have X label and Y label. So what we can do when it comes to the line, one thing is we can set the line width to be equal to, let's say, 10. And as you can see, our line is much wider than it was before. Probably not the best line width that you can use, but just so you know that this is how you can set it to a different width. I'm going to remove this. I'll just stick with the default. That looked much better. What else we can do is, if we want to display the data points much better, then we can use marker equals and then specify some marker. So I personally like the O or the circle. It looks very nice, it looks very professional, and marker size would be equal to 15. And what this does is it creates a circle on every data point that we have. So if you take a look at this straight line that we have between day 1 and day 3, now this makes it clear that there is actually one extra data point in between, that it's not a line going from from the first to the third day. So it makes day 2 a bit more visible. And if you, for example, have some data point that's somewhere in between these lines, so you can't really see if, for example, in day 6 we have a sales of 160 or 150, what you can do is you can use plt.grid, and if you don't specify anything, it just sets grid to true, so it appears on our line chart. And this also helps, and I do use it often if it makes the line chart look better, if it adds value to it. If not, then of course you don't have to use it. And you can change the color of the grid, so these horizontal and vertical lines, just by simply adding color equals and then, I don't know, maybe green. Let's make sure that it's visible. And same goes for the color in our line related part of the code. So we can also set that to, I don't know, red. Let's just make sure that it's visible, but of course it wouldn't look great. But sure enough, we have the color of our grid set to green, and we have the line itself with red color. So the title and the labels are quite similar to one another. And what we have when it comes to the grid and the line itself, the main line, well, they're also quite similar between each other. Of course, we can't have marker size or markers on the grid because there is no data point, it's just a horizontal and vertical line. However, we can specify the color, and what we can also specify is the line width, which is same for the plot, the main line that we have, but we can also have line style. And the line style we can set to, for example, just one dash, which is a solid line. We can set it to 2 dashes for a dashed line. We can also set the line style to, let's say, dash dot. And let's see how that looks like. So we've set a dash dot for our grid, and we have a dashed line for our main line. So this is just something that you can use. I don't know how much you want to experiment with that, but it's an option out there. And what I want to cover before I add the data points for the second company is that you can combine the color, the line style, and the marker into one string when it comes to the plot. So for the grid, I'm going to remain with the default one. So I still want to see the horizontal and vertical lines. I don't want to have any other color or line style. I'll leave it to the default. So what you can do is, as part of it, like after you have the X and Y data points, what you can do is you can specify the color of your line. So in this case, it's red, so R. Then you can specify the marker, so that is the O, and then you can specify the line style, which is 2 dashes. And then I'm going to remove this part of the code, which is related to exactly what is specified in here, and we should get the same result. So as you can see, the grid is back to the default, and we have the red circle with dashes in between them. And even though this makes our code a bit shorter, maybe it's not best for the long run, because if you read this now, you know what it means. So red circles connected by dashes. But if you read this maybe a few months later, then maybe you're not sure what that means, and then you need to spend some time researching. While if you go back to what we had before with the marker and the line style and the color, that's much easier and much easier to read, and also much easier to later on change if, of course, that is necessary. So I'm going to stick with the separate part. So marker is equal to a circle, color is red, and we're going to go back to blue, and line style is just dash. Now, if you only use one line, just as we have in this case at the moment, there is one more thing that we can use to make our line chart look a bit better, and that's plt.fill underscore between, and we pass our X and Y data points, so the days and sales underscore 1, and what we pass is also the color. So let's pass the color blue again, and what this does is it fills the area that is between 0 to our data point. So this is how it looks like. Maybe in this case you would not want to use the grid. Maybe that's better because it doesn't add any value. So maybe this looks better. Now, one thing is that it looks exactly the same color as our circles, which doesn't look very nice. And often what is advised in this case is to set alpha, which is a transparency of our fill part, to something that's closer to 0. So not 0, it's a value that goes between 0 and 1, so it makes it transparent or non-transparent at all. So this looks a bit better. Of course, having the grid or not, it's a personal preference, whatever you think looks better. But what you can notice is that the y-axis now we have starting from 0, and before it was from, I think, somewhere around 130 or 140, which looked a bit better. So let's see how we can keep the fill between, but also have our axis, let's say from 140, let's make it 130 to 190. There is a simple code that we can write, and it works for both X and Y axis, and that's plt.xlim and plt.ylim. Now the X limits we're not going to adjust because that's fine for this example. But in here we pass the X and Y, the starting and ending points that we want on the axis. Or in this case, we want 130 to 190. So on our Y axis, we would get the points, the ticks starting from 130 to 190, and it looks much better than it was before. Now, if you want, for example, to have here instead of every 10, you might want to have every maybe 5 or maybe even every 20 points as ticks. That's something that you can change by setting plt.yticks, and then you should pass a list of the ticks. So 130, 150, 170, and 190, and we have changed our y-axis to look a bit different than it was before. And this works same for our x-axis. I don't know, in this case, it doesn't make any sense to change that, so we're going to leave it as it is. But if you want, you can just use plt.x limit, so the starting and ending point, as well as the y-ticks. This is something that I would do if I have multiple line charts. Actually, regardless of the number of lines, I would do this at the end, because first you have to make sure that the data appears nice before you actually adjust the axis. Actually, let's see an example of why you should adjust this at the end. So if this was our ending point, then that's fine. But if, let's say that, and I'm going to add the sales of our second company, and we're going to have data points that are outside of our limit. So we're going to have 70, then 90, and then I'm just going to take the 5 data points of our first company. So this is data sales of company 2. And we're going to plot this. One thing that I'm going to get rid of is this fill between, because if you have multiple lines, then it doesn't really make sense unless you want to see the overlap. But in this case, that doesn't really add any value. So I'm going to remove this, and let's plot plt.plot. Now we're going to plot days. We're going to plot sales 2. Marker would be a star. Marker size 15, color equals red. And line style, let's use a solid dash. So this is line related company. Oh, it's a line company 1 and line company 2. Now if we run this is what we're going to see. Because we fixed our y-ticks to be between 130 and 190, we no longer see the data points that are relevant. But yeah, so we need to, so this is why I would advise you change the axis at the end. Until you have the data points, until your lines look good, don't change the axis. So what I'm going to do now is, since we have data points starting from 70, I'm going to start from 70. The second mistake that if we do only this is the ticks that would appear are 130 to 190, because that's exactly what we've specified. And also our limits, although they start from 70, that's exactly where our point is. So we need to adjust that to a bit below, so maybe to 60 or 50. So let's start with 50, and I'm going to add here 50, 70, 90, and 110. And now it looks a bit better than it looked before. So again, make sure that you have the data points, make sure that you have your desired output well before you adjust the Y and X axis, and especially if you add ticks manually or adding limits. But if I comment this out, actually what happens is we get the defaults from Matplotlib based on our data points, and it would look quite nice. So first, check how the default looks like, and if it looks good, then maybe there is no need to add any custom limits or ticks. What you will notice is that sometimes you will have, for example, here 80 and then 85 and then 90. So if you have a lot of data points, a lot of ticks, then that's when you might want to use these white ticks. Or if you want, for example, to start from 0. So if I want my limits to be starting from 0 to 190 and I want to see the whole picture, then I would use this. But for the rest, I often do stick with the defaults and see how that works. So again, make sure that you have the data points, check the defaults, and if necessary, then make changes when it comes to the limits of the axis and the ticks. Although we have the lines, what we don't know is, well, which line is related to which company. Well, that is something that we need to still add, and we do that by adding labels to the lines. So what I mean by that is, label of our first line would be equal to company 1, and label of our second company would be company 2. Now, if we run it as it is, of course, we're not going to get any text because it's just a label of the line. It's not shown at the moment, but it appears as part of the legend. So I'm going to use plt.legend, and at the moment we're going to not pass anything in the brackets. So let's see how the default looks like, and then we're going to change that. So we have a legend appearing to the top left, and as you can see, the blue circles are related to company 1, the red stars are related to company 2. But let's face it, the position of the legend is not perfect. There's a lot of empty space on the bottom right part of the screen. So let's change the location there, and maybe also change our limits of the y-axis to start from 50 to maybe 190 is fine. So, and then maybe change the font size of our legend to increase it a bit. So the limits we're going to set starting from 50. Our legend, the location we want it to be to the bottom right part. Now the way we do that is the location has basically we pass a string that has two parts. The first is we either want it to be upper, center, or lower, and then space, and then the second part is left, center, or right. So these are the combinations. So we can have it upper, left, center, right, center, left, or actually when it's center you can just leave center, and then if you want it the lower part, which is what we want now, what we're going to do is lower, and then we're going to leave right. So those are the possible combinations. And font size I'm going to set to 80, so a bit larger than our X and Y labels. And this is how it looks like. So it looks much better than it looked before. And there is one more thing that we can add to make it even better. For example, if we would like to set the average of the sales and then see which days were above or below average, or maybe if we had a target of 150 sales a day, then we can add a horizontal line that shows what is the target, and then again we can see which days the companies performed well and which days they didn't. So what I'm going to do is I'm going to have a plt dot x horizontal line at level of 150 sales, and let's set the color to be equal to black, and line width of this line would be 3 pixels. So this is just the horizontal line target of companies, target sales of companies. So this is how it looks like. So we can see that company 1, for example, on the first day it did more sales than the target. The second day it did 150, which was as the target amount, then it went a bit below. So it's quite clear to see what, or of course you can set this to be equal to the average sales and see which days were performed above, on which days performed below average. And this would be all regarding the line charts. Of course, if you have any questions or comments, let me know in the comment section below. We're going to continue with bar charts next, and for those of you who skipped the tutorial up until this part, the dataset that we have is the days of the week, saved as 1 to 7, and we have sales of 2 companies, and we're going to start by creating one simple bar chart and then build on top of that. So the code that we had from creating the line charts, we're going to get rid of everything except for the plt.figure. That line of the code, what it allows us to do is, first of all, we set the ratio of x to y, so we have 6 to 5, and the DPI, or the dots per inch, of 150, which is higher than the default, so our graph looks a bit larger, and of course for the purpose of this tutorial it's much easier to see as it changes. So our first bar chart would be a simple blt.bar, and in the brackets we're going to specify the data points on our x and y axis, so the days, and let's start with the sales of company 1 and then plt.show. So simple as that. We have our first bar chart that looks like this, which has no additional information that are useful, so we're going to work on that. First, let's add the title and the X and Y label, and then let's see how we can modify the bar chart. So before we show our plot, plt.title would be sales per day. We can also set the color to equal to blue, and the font size will stick with 20. So for those of you again who are continuing this tutorial from this point, know that these are the things that you can change when it comes to the title, and it all goes into one single line. plt.x label, we have day of the week, color equals blue, font size equals, I'm going to stay with 15, and plt.y label sales color equals blue, font size equals 15. So simple as that. We have added few additional information that makes our bar chart look a bit better than before. Of course, there's a lot more that we can still improve. Maybe we can change the width of these bars. Instead of the default of, I think, 1, we can change that to be equal to 0.5. So of course, if you want these bars to be wider, this is how you change that. Now let's plot our second data set. So the sales of company 2, plt.bar days, and then sales 2. So on our x-axis we would have the days, and we would have on our y-axis the sales. With, I'm going to set them to 0.8, and I'll in a second you will see why. And I also add comments. So these are sales of company 1 and sales of company 2. So if I run this, what you're going to notice is that some, of course, bars are wider than others. That's something that we expected. But for the day 3 and 4, we have no clue what the sales are for whichever company it is that has blue bars. Now, first of all, we're missing, of course, the legend. And second of all, we can't see all of the sales. And the reason for that is because we first plotted the bars with 0.5 width and then the bars with 0.8. So if we have higher values for those days, then we won't see the bars that were plotted in the first place. Now, one way to solve it is if you make the other way around, so 0.8 for the first one, but in my opinion, this looks terrible. So even though you can still see the sales, it looks terrible. I wouldn't personally use this. It is a simple fix, but it looks terrible. So what I'm going to do is I'm going to have same width for both bars. I'm going to include label. So this is the company 1, and just to make sure that we know which company has which color for the bars, and this is company 2. And let's add the plt.legend. And now if we run this, we see a very nice legend, at least we know, but we still don't have the sales for the 3rd and 4th day of the week. And maybe it's good to have that change to Monday to Friday instead, because this is no longer a long time series. It's just a nice simple bar chart with only 7 days. So we're going to change that. But how do we get the 2 bars to look much better than it is at the moment? Well, for that purpose, I'm going to import numpy as np. And this is the reason why. I'm going to create an array, which would be equal to np.arrange length of our days. So what this is basically 0 to 6 array. And I'm going to use that one instead of our days in here. So we're going to plot on every x position plus 0.1, so a bit more to the right for the first bar, and x plus minus 0.1 for the second one. Now simply by adding these two, our bar chart looks much better than before. There is no data point that we don't see. It looks much more professional than before. But what is missing is now the x ticks have changed from 0 to 6. And that is something that we can change. Again, fairly simple, but let's also make sure that instead of these days, we have days of the week, which would be equal to Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. So we would like to have those as our ticks. And the way we do that is plt.xticks. Well, what we want is on every x position, so what we generated in here, we want to have days of the week. So simple as that. With just adjusting a few lines of code, we have our days of the week, so from Monday to Sunday, and also the bars look much better than before. We can see all the data points. And with the data that we have, I would personally be happy with this result of having such a bar chart, because it's clear to see which bars are related to which company. We can see which day of the week, and then we can also match with the sales. We can argue that maybe we need to have a bit more distance between the two bars and maybe make them a bit wider, or maybe not as wide as they are, but of course that's personal preference. But there's one more thing that I would like to cover when it comes to the bar charts, and that is creating horizontal bars instead of the vertical ones that we have here. The way we do that is, well, instead of plt.bar, we would just use bar h, which stands for horizontal. And now there are a few things that we need to adjust. Well, first of all, we're going to have these as y positions instead of x positions. And we need to adjust that in our plots. Then, of course, sales would remain as they are. Width, we no longer have width, but instead we're going to have height. So when we have the bars displayed horizontally, then we have height of the bars that we can adjust. The width is actually the sales point, so we're not going to adjust that. So if we start from the top, then first we have the y positions, which is in our case, the length of, in this case shouldn't be days, it should be sales, but we would get the same outcome as, of course, both have the same length, so the same number of data points. Then we remain with the same figure size. Then we have created two separate horizontal bars, one for each company. The title remains the same, the X label remains the same. Actually, the X label would be different now. We would have what we had on the X label now would be on the Y label, and then the other way around. The X ticks, what we had before, now are the Y ticks, and that is equal to the Y position. So the X we don't change, the Y position is what we change. And I'm going to run this, and let's see what we get as output. And here it is. So it is what we expected. Of course, if you want to increase the height of the bars, you can do that. One thing that I would personally adjust is this legend, because it overlaps with part of the data. One way to solve it is to extend this x-axis. So it starts from 0 to somewhere around 180 at the moment. So the limits, I want them to be between 0 and, let's say, 210 maybe, or 200. So let's say how that looks like. So plt.x limits between 0 and, let's start with 200 and see if that is sufficient. Maybe a bit more. So maybe let's make it 220. And then even what we can do is we can make sure that here the ticks go up to 175. Maybe we want the ticks to be 0 and then 50, 100 and 150. And maybe 200. So you can change that. If you don't want to display all, you can have plt. Maybe we can do that after setting the limits. So plt.x ticks, and then we can pass the list. Let's say 50, 100, 150, and 200. And that looks a bit better. I would not personally use grid to this. I think it would make it look worse. But if you started this tutorial from this point, then it's good to know that plt.grid is how you can incorporate the grid to our bar charts. So this would be all when it comes to bar charts. And if you have any questions or comments, let me know in the comment section below. And if not, of course, we continue with the rest of the tutorial. We're going to continue with scatter plots, which are mainly used to show how one variable affects another one. And if we have two datasets that are highly correlated, then you should be able to notice that once we plot them. For example, if we have data regarding the company's expenses regarding marketing, then we should also expect that there are more customers because we've spent more. Of course, if the same company spends less, then there should be less customers. This is a positive correlation that is expected. Of course, it might not be the case. Another example would be, for example, the more it rains, the more umbrellas are sold. And this is, again, we start with the assumption that there is a positive correlation there. But by plotting these numbers on a scatter plot, we can make that clearly visible. For our scatter plot example, I'm going to remove all the code that we had so far, except for this POT figure, because I think the way it looked in this video is quite nice, so I'm going to stick with that. And the data that I'm going to create would be number of hours spent studying. So let's say 5 hours, 6, 7, 8, 10, and 12, and 14. So we have 7 data points and we have exam points, which should be correlated with the number of hours spent. So we're going to start with maybe 45, 50. Then we have an exception of someone with 90 points that studied 7 hours. Then we have 60, 70, 80, and 100. So 1, 2, 3, 4, 5, 6, 7 with 2, 4, 6, 7. So we have 7 data points in each. And what we're going to use in order to create a scatter plot is plt.scatter. And of course, in the brackets, we're going to specify the data that we want to appear on the X and Y axis. So number of hours and exam underscore points. And let's set the color to be equal to green. So we want whatever is shown to be appear as green. And of course, we have to show that. So this is how our first scatter plot looks like. We still miss the X and Y labels. We still miss the title, and these circles are quite small, so maybe it's good to increase the size as well. So let's add first the title and also the labels. plt.title would be equal to exam points per hour studied, color equals to green, font size equals to 20. plt.x label would be number of hours spent studying, color equals green, font size equals 15, and on the y label we have exam points, color equals green, font size equals 15. Now, in order to change the size, in the previous examples, we had a marker that we could use marker size to change, but in this case, we don't have that. What we have is S, which stands for size, and we can change that to, let's say, 300. And if we run this, now we should be able to see circles that are a bit larger than before, and this is how it looks like. Of course, you can change the font size if, for example, you think that the title is way too large, or maybe insert a new line so that it's not that close to the edge of our scatter plot. Now, once you're done with a scatter plot, you have your elements. I would advise you to be critical to what you have used so far. So for example, the title, is this the best title that we could have used? Probably not. We can just have student overview, and then on the X and Y label, we already have the information of what is the overview related to. So here, instead of number of hours spent studying, we can just have study hours, exam points. That's clear enough. And let's run this as it is, but maybe let's also add the grid, because this is a nice example in which grid would add value. So as you can see, maybe it's not actually that good, because it cuts these circles and in quarters or in half, so I'm going to get rid of that. But as you can see, the descriptions are much clearer than before. So this is the student's overview, this is how many hours he or she spent studying, and this is the exam point. There's a clear upward trend. The more hours studied, the more exam points, except for this one person who is the exception. Now, one more thing that I would like to cover is this size. Actually, two more things. One is the marker that you can change to, let's say, a plus or a star if you don't want to use the default circles. And the second one is this S that stands for size, because at the moment we provided a default size for all of the points. And as you can see, this is how a size of 300 looks like. But what we can use is we can have the size of the marker to be related to, let's say, to our exam point. So the more exam points, the larger the star, and of course the less exam points, then the smaller it appears. So what we can do is we have our sizes to be equal to 300, but what we can have is we can have exam points, and then I'm going to multiply this by 3, because if we have these 45 to 100, that would appear quite small, but if we have it multiplied by 3, then we have somewhere around 150 to 300, and we saw that 300 looks fairly nice. So simple as that. We have our 300 size start to the top right and our 150 to the bottom left, and as you can see, there's a clear correlation between the exam points, the study hours, but also the size of our stars. You can use circle again if you just remove the marker and go back to the defaults, but it's up to you to make sure that it looks nice. Of course, a lot of that is just personal preference. Next, we're going to continue with histograms, and what a histogram is used for is basically to show a distribution of data. So for example, right here we have the number of hours spent by a student studying, so we can create a distribution to see how many students spent, for example, between 5 and 8 hours studying, how many spent between 8 and 12, how many spent over 12, and so on. First thing what I'm going to do is I'm going to add a few more data points. So we're not going to have only 7 points, we have a bit more now. And I'm going to get rid of the code that we had so far from the previous part of this tutorial, except for this plt.figure, because that's, as we said before, it looks quite okay. So we're going to start from here, and we're going to create our first histogram. The way we do it is we use plt.hist, and then in the brackets we specify our dataset number of hours. Of course, plt.show to show the histogram once we run this script. Now, if you remember from all our previous examples, the first plot that we have is always terrible, and there's so many things that we need to change, and this one is no exception. If you use plt.hist and only specify the data, then this is a good example of a bad example. So this is something that you should not show to anyone unless it's for learning purposes like this one. So there's so many things that we need to change, and we'll do that now, and of course we'll get to a much better histogram than the one that we currently have. Where do we start? Well, let's first add the title and the labels just so we know what this histogram is related to, and then maybe change our white text instead of having 0.25, 0.75, because they add no value, to 1 to, let's say, 5. I know that we don't have 5 data points at a given bar at the moment, but we'll get there. So plt.title, what we have is we have the study hours, the font size would be equal to 20, and color, let's set it to blue. plt.x label, so on our x label what we have is we have the number of study hours, font size is equal to 15. Actually our title would be distribution of study hours, and color equals blue. On our y label we would have number of students, font size equals 15, color equals blue. plt.ythix, we have 1, 2, 3, 4, and 5, and at least we have some more information regarding our histogram. We still can't separate, for example, the first 2 bars where the first one ends and where the second one starts. One way to do that is if we change the width of our bars. Now the difficult part in this is we can't use width. We can use width, but it's more difficult to see how wide each bar is because we don't really know the data points. But for that reason we can use relative width. And instead of having it at 1, which means if you have it at 1, it means that all the bars would be connected one to another if there are data points. But with the relative width, you can just set that to 0.9, which means there would be a bit of space in between. And as you can see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that is the default number of bins provided by matplotlib.hist. So when it comes to plotting histogram with Matplotlib, you get 10 bins by default. You can change that by just having bins equal to 5, for example. It might be sufficient sometimes just to do that. we still need to change these ticks on our x-axis, so we don't want 5 and then 7.5. What we can also, well, there are many things that we can change, but let's do them one by one. We can also change these bins. Instead of having 5 bins and then calculating this, the difference, oh, actually the bin width automatically, what we can do is we can have bins equal and then pass a list. Let's say 4, 8, 12, 16, 20, 24, and 28. So those are the bins that we want to have. And let's also have those as x ticks. So we have the same text. And this is how you can read this histogram. So if you take a look at the points 4 to 8, so between 4 and up to, but not including 8, we have 3 data points. And if we see in our data, we do have 3 students that studied for 5, 6, and 7 hours respectively. Then between 8 up to, but not including 12, we have 2 students, which is also the case, and so on. So this is how you can read the histogram, the distribution of the histogram. Now you might think, well, there are many bars. Maybe we want less bins, maybe we want more. That's personal preference. One thing that I would like to mention here is if you want to show where the average is, then what you might want to do is you might want to display, for example, a vertical line, so plt dot axv line, and let's say that the average is somewhere around 30 hours. Color equals black, so we want it to be a different color, and label would be equal to average study hours. Now when we have a label, of course we want to have the legend so we know what that line represents. And as you can see, now we have this line and it shows where the average study hours is. And it adds an additional information. If you, for example, say, well, I just want to have, I don't know, maybe between 4 and 28, I only want to have 2 bars just to separate the students into 2 groups and see how many of them maybe study 15 or more hours. So what you would do is you would have 4 and then 16, so it would go up to 15, won't include 16, and then let's say over 16. So if you have 4, 16, and 28, all you do is you separate these all the data points into these 2 plots or 2 bins, and this is how it would look like. So although it looks okay, what we need still to adjust are these x ticks, y ticks, because now they go only up to 5. Now, before adjusting any of the ticks, I would say just check and see how it looks with the default, and if it's sufficient, then maybe you don't even need to change that. And as you can see, we already have 0 to 8, so I would personally leave it as it is. And I would like to mention that what you can do is you can plot a horizontal histogram. And let me add maybe just a few more data points here. So just so we have more bins. And the way we do that, the way you convert this vertical histogram to a horizontal one is by specifying orientation equals horizontal. Now, that's not sufficient, of course, that's not the only thing that you do, but this is the main part, because if you only do that, the plot is horizontal, but the text and a lot of what we actually had set for the previous histogram now is no longer relevant, because we don't want number of study hours from 4 to 28, because those were our x ticks, but now we want those ticks to be our y ticks. Also, our labels, number of students, this is not correct anymore, it's the other way around. So when we change the entire histogram from vertical to horizontal or the other way around, all you need to do is you need to change these x and y labels and the x and y ticks. Now in our case we have only the y ticks, and it would look much better than it looked before. Now of course, one more thing is this average study hours, because that's no longer the case, and actually this is causing our x ticks to be up to 13, because this is no longer a horizontal line, a vertical line, that should be a horizontal line. So the way you change that is you change this v to h, And simple as that, you have converted a histogram from vertical to a horizontal one. And of course, if you want to change maybe this legend, if you want to display it somewhere else, or maybe you want to have a new line, you can also do that. But yeah, that is something that's personal preference where you would like to have it. And maybe one more thing before we wrap up the part regarding histograms, and that is we can add edge color to be equal to, let's say, black, and that would create this nice outline of our bins that we didn't have before. Again, it's a personal preference, colors as well, so it's up to you to decide whether this looks good on your histogram or not. And let's quickly sum up what we have in here. So we have our data set, number of hours of study for some students. Then we have created our histogram. We've specified the relative width of the bins. We have, or of the bars created by the bins. We have our bins manually specified. We know how to create a horizontal one or a vertical one, as well as add edge color. We have a horizontal or a vertical line to display either average or sometimes a target. We know how to add a title and labels, which is exactly the same for any plot that you have. Also change the Y and X text if necessary. And of course, if you have any questions or comments, then let me know in the comments. Otherwise, we continue with the next part. And for the next part, we have the pie chart. So we're going to get rid of the code that we have so far, including the data set, because, well, it's not the most appropriate data set for a pie chart. Instead, we're going to create two lists. One would be our expenses, which would include, let's say, food, rent, maybe, let's say, books, sports, and other. And then we will have the values of these expenses. So let's say we have 500 for food, 400 for rent, 300 for books, 250 for sports, and let's say 700 for others. So for other expenses. And the simplest, the default pie that is being plotted by Matplotlib would be, if we use plt.py, we pass our values, which would be used to be for the creation of the pie, and then our labels would be equal to the expenses that we already have. And of course, plt.show if we want to show this pie. So this is how the default pie chart looks like. At least we know that we can see clearly that, for example, the other is the largest portion of the entire pie. Then we have food, rent, and so on. But of course, there's a lot more things that we cannot add to this. So let's start and see how we can change that. I'm going to start by adding the title, which is overview of expenses. My font size would be equal to 20. For the color, I'm going to choose red just so it's different than our previous examples. Adding X and Y labels in this case doesn't add any value. I mean, there is no reason why we should add that. Adding a legend also doesn't add any value because we have everything that we need displayed via these labels. So we're not going to change that. If you want your pie chart to be larger or maybe smaller, you can change this radius to be equal to, I don't know, 1, 2, 3, or any integer. Probably it works also with a float. So if we choose 1.5, we should get a larger radius. Of course, in this case, we don't want that, but if you want to increase or decrease it, and this is how you would do it. But what I would like to have is, I want to know the percentages. For example, how much percent of the total expenses are related to food. And in order to do that, what we need to do is we need to have auto PCT, which would be equal to a string. Now in here, we would have 3 percentage points, and between the first one and the second and third, we're going to specify 0 and then F. Now what this means is it would show the percentages, but with as many decimals as possible. And this is not what we want, right? We would want to have maybe 1 decimal points or 2, but not that many. So if you want to have no decimal points, you would just add a dot and simple as that, you only have all the percentages rounded. If you want to have one decimal point, you would add 1 and you would get this. If you want to have more decimal points, such as 2 decimal points, you would change this to 2. So 0 is for the percentages, and then after the dot, after the point, you get the number of decimals that you want to have. So I'll stick with 2 decimal points. I think that's fine. And what I would want to do is I want to have this other part of the pie not linked to the pie itself. So I want this to be a bit separated, just to show that if this is the overview of our expenses, that maybe we should pay more attention to this other part that we can't really classify. Now, in order to do that, what we can do is you can use explode equals, and then in this list we would pass 0 for the ones that we don't want to explode of the pie, and maybe 0.1 or 0.2 for the ones that we want. So we have 5 different expenses. So the first one, second, third, and fourth, I want to remain as they are. For the other, I want 0.1. So I want it to explode a bit from the pie and to be separated. So this is how it looks like. You can have all exploded just a bit, like 0.05 if you want to have some space in between them. Let's see how that looks like. Maybe that also looks nice, but it's as all the other charts, it's a personal preference. So this is up to you to decide what looks best. You can change also the colors, so you can pass here colors equals, and then maybe we want the food to be equal, I don't know, blue, then we want red for rent, we want green for books, I don't know, purple for sports, and yellow for others. And this is how it would look like. So our colors match the order in which we specify. So we have blue for food, we have red for rent, and so on. Now, some people might want to create a so-called donut, and there are many ways to do it, but personally I find the easiest one if you just add one more pie chart on top of the one that you already have. So plt.pie. The values would be just any values, but let's say that there are 2 values that we want to plot, or even 1, but let's stick with 2. Labels would be equal to none, so we don't want any labels, and the radius would be equal to 0.4. So we want this second chart to create like a hole in our first chart, and the colors would be white and white. So nobody will notice that even that pie chart exists. And let's see how this looks like. So we have a donut, but as you can see, we have some color in here, which we want to get rid of. And if you want to do that, is basically the pie chart that we have apparently has a bit of explosion already in it. So we need to reverse that. So in order to do that, what we need to do is explode equals, and before that we had 0.05, now we can have minus 0.0, even 0.5, and also for the second piece. And if we do this, then, well, we get our donut, which looks much better than before. And actually, this is all that I would like to cover when it comes to plotting pie charts or donut charts as well. So whatever you want to call this. I hope that it is helpful. And if you have any questions or comments, of course, let me know in the comment section below. The next and last type of plot that we're going to cover in this tutorial is the so-called stack plot. And the name itself suggests that there are plots that are being stacked one on top of another. And let's see how that looks like. But for that purpose, we're going to need a different data set than the one that we have. And instead of having expenses and values, what we're going to do is we're going to start with some activities that usually a person does over the course of a day. So we're going to have eating. Let's have sleeping, reading, and playing. And we're going to have a value for every day of the week. So the days would be 1, 2, 3, 4, 5, 6, and 7. So we're going to have 7 values in every list that we just created. So eating, let's have, so we have 7 values. Let's say that on a Saturday we spent more time because of some social gathering, for example. Then sleeping, the average is about 7 or 8 hours. So let's have that. Reading, I had 7 more data points, and playing. 2, 4, 6, 7. So we have 4 lists, each of them having data points for every day of the week. And what we're going to do with these 4 lists is we're going to create one plot that would display all of them stacked one on top of the other. So plot.stackplot. And first we're going to have our x-axis, which would be the days, and then we would have every activity. So eating, sleeping, reading, and playing. All of them separated by a comma. And let's see how the default stack plot looks like. So plot.show. And this is how it looks like. Of course, we still don't know what each color represents, so which activity it is, but we can see, for example, that there are 7 ticks on our x-axis. We know that that represents the number of days, but of course we need to make sure that it clearly appears here. So let's add the title. So plot.title, and the title is activities in a week. Let's have the font size to be equal to 20 and color equals green. So we're going to use green for this example. plot.xlabel. On our x label we have day of the week. Font size equals 15, color equals green. And on our y label we have number of hours. Font size equals 15, color equals green. So if we run this as it is now, we have some additional information. It looks much better than it was before, but yeah, one more thing that we still need to adjust are the labels to make sure that we know which color is related to which activity. So in order to do that, as part of our plot.stackplot, we need to create labels, and the labels would be basically the activities that we have. So in our case, we have eating, we have sleeping, reading, and playing. Now, if you run it as it is, you would not have any change when it comes to the plot because we still need to show the legend. So plot.legend, and this is how it looks like. Of course, we can change the location instead of having it on the upper right side. So location would be equal to upper and then left. And that looks much better. Now we can see that the green color represents how much of our day is spent on reading. The red part is spent on playing. And so this is the purpose of the stack plot. As you can see, all these plots are stacked on top of one another. What we can do is we can also manually change these colors. So maybe we don't want red for playing, maybe we want green for playing. And if that's what you want, then you can set the colors to be equal, and then you could pass the colors in here in this list. So the first activity is eating. So let's say that we would like to have blue color for eating. For sleeping, we would like to have green. For reading, maybe you want to have red, and for playing, we want to have yellow. And if we do this, then we get an adjusted color-wise stack plot that is according to what we've just specified. Of course, we already covered how we can change these days of the week. Instead of having 1 to 7, that they appear Monday to Friday. If you started this tutorial from the stack plots, then check the descriptions and I'll make sure that I include a timestamp for that as well. Matplotlib comes with a few styles that you can use, and that's applicable not only to stack plots but in all kinds of plots. So this is of course what the default is, and if you want to know what kind of styles you can use, what you need to do is if you print plt.style.available, you will get these styles. So let's check how do you use one. Well, the way you do it is you need to use plt.style.use, and that in the background you would use, let's say, a dark background. So plt.style.use, and in the brackets we would have dark underscore background. And if we run this, then of course our stacked plot looks different. Find whatever works best for you for your chart or graph. The most used ones are probably 538, which looks something like this. And as you can see, we have the grid on the background, not as part of our plot, and ggplot, but which looks like this, which has a lot of similarities, but it looks of course different. And if you use it for lines and for bar charts, then you would notice the difference a bit more. So again, use plt.style.available, print that to see the available styles, see whatever works best for you and choose that one. You can also show multiple line plots on the same figure, and for that purpose I have on the right side a specification of a grid, and we're going to try to recreate that same grid with, as you can see, 5 different line charts. Of course, first we need some data, and we're going to keep it simple. So our x-axis would be 1, 2, 3, and 4, and on our y-axis for our first line chart we have 4, 3, 2, and 1. So let's try to plot this first axis, and then we're going to build the rest as well. So how do we do that? How do we instruct Python that we want this specification and this is the position of our axis 1 and 2 and 3 and 4 and 5? First of all, we need to understand and see how many rows are there on our specification. Now, as you can see, this is our first row, this is our second row, and here is our third row. So we have 3 rows, of course. It starts from 0, so 0, 1, and 2, and we have 3 columns. So this is our first column, this is our second, and this is our third column. Why is that important? Well, when we create plots, we create all these subplots separately. So we would have ax1, which is our first subplot, which would be equal to plt.subplot2grid. And then in the brackets, we have a few tuples. The first one is the dimensions of our grid, which is in this case, we saw it's 3 by 3. Then what we specify is the starting point of our plot. Now in our case, we have 0, 0. And if we run it as it is, so if we use plt.show, at the moment we don't have the data, we just create these subplots. We've never specified that it should take x and y1. What we would see is that it creates this. So it does divide the entire figure on 9 pieces, so 3 by 3, and it plots this one on the top. But that's not what we want, right? We want also to have this figure going, this line plot going all the way to the right, which means the column span should be more than 1, but it should be 3. So col span would be equal to 3. So if we do that, we specify the starting point of our line plot and also how many columns we want it to be wide. Then if we use ax1.plot and we specify x and y1, then we also add the data, and simple as that, we have our plot it's aligned with our expectations, so we have the data also included, and we can do the same now for the remaining part. So ax2, but of course we also need the y2 data, so let's say 10, 20, 30, 40, and let's also add the data for the other plots, 40, 30, 20, 10, y4 would be 1, 2, 1, 2, and y5 would be equal to, let's say, 50, 60, 80, 90. Of course, these are just information that we need just to make sure that the plots appear, and I want to make sure that they are different so we can compare whether we have them on the right position or not. So ax1 would be equal to plt.subplot2grid, and then the dimension of the grid still remains 3 by 3. Now the starting position of our second line chart, as you can see, it should start at row 1, column 0. So it should be 1, 0. The row span in our case should be 1, so we're not going to change that, but the column span should be equal to 2. So it should not go all the way to the end as it was the case with our first axis. It should go only 2 columns to the right. So ax2.plot, we're going to plot x and y2. ax3 would be equal to plt.subplot to grid 3 by 3. And now let's see what are the starting positions. So ax3 starts at row 1, column 2. So it should be 1, 2. When it comes to the column span, it's just 1 column, so we're going to leave it there, but the row span would be equal to 2. So it goes a bit below than it's the row that it starts. And we're also going to plot ax3 with the data x and y3. So let's take a look at how this looks so far. This is what we have. So as you can see, it's aligned. Of course, we're going to see how to add labels and also how to make sure that there's more space in between. Let's also add ax4 and also add ax5, which would be equal to plt.subplot to grid. So first we create that subplot and then we fill it with information. So in this case, we would have a start. The 3 by 3 remains the same. The starting point of ax4 is row 2, column 0. When it comes to the row span or column span, we don't have to specify anything because, well, the default is good. It would just be 1 row and 1 column. ax5 plt.subplot to grid 3 by 3, and the starting position would be row 2, column 1. And of course, again, the column and row span, we can leave it as it is. And let's also include the data. So ax, the number dot plot. So we have the same y information, the same x information, and then the y would different. So this is how it looks like at the moment, and it's quite aligned with what we have. But let's also see how we can add the labels, how we can add a title, and then maybe how we can also adjust the angle of these ticks. And also let's see how we can add a bit more space in between these charts. So the first thing when it comes to adding labels is ax, and then you choose your axis. So let's say in the first one, we want to set _x label. And in the brackets, we're going to specify the labels. So let's say this is our x label of x1, ax1, font size would be 10, color equals blue. So if you want to set ax5, so let's say y label to our 5th axis, we're going to say just to name it as y label of ax5, font size equals 15, color equals, say, green, just to make sure that we have it correct. And let's see how it looks like. Well, we don't see them, right? So we don't see our X label on AX1. We don't clearly see, and the reason for that is because it's somewhere in between here. So we don't see that. So what we need to do is we need to make sure that there is more space in between these charts, but also maybe change the size of our figure, because we had that before, now we don't have it. So let's increase the figure size. And also, let's see how we can adjust the space between these charts. To adjust the figure size, we're going to use plt.figure. Fig size is equal 6 by 5. This is not only the ratio, this is also the inches. So we have 6 by 5 inches, and then dpi is how many dots per inch we want to have. So let's keep with what we had before. And what we want to do is, let's add that space in between. So the way we do that is, if we have, let's say plt.subplots _adjust, and in here we can specify h space, which is the space height wise, so the height space going from top to bottom or the other way around, the space that we have between the chart. So let's set that to 2, and W space is the width space, and let's say also that to 2, and see how that looks like. Maybe it looks better, maybe it looks worse. So as you can see, this space that we have is a lot more than we need. We can see at least our label, so that is a bit better. We didn't include that to all, but at least you get the point that this is how you would adjust. You need to find, of course, the right space between these 5 charts, and you already know how to create these subplots on our grid. Let's try to fix this a bit. So we don't need that much height space, so let's set it to 1, also the width space. Looking at the font color, we can reduce that to 10. And what else I would like to cover is you can change the angle of the X and Y ticks. So what we can do is for label in AX1 dot, let's say X axis dot get underscore tick labels, label dot set underscore rotation, and let's say it -45. And let's see how this looks like. So we would expect that the ticks of our first one are rotated, and this is indeed the case, and having a bit less space when it comes between the charts makes it look a bit better. And yeah, just make sure that you get the right space in between, and you can add as many titles as you want. Make sure that, again, they don't overlap. So this would be all when it comes to subplots. If you want to save any of these, then that is also done quite simple. All we need to do is use plt.save fig, and then in the brackets, what we need to specify is the image name. So let's have it as final figure.png. And if we run this, we would get the figure shown. And also if we go to the folder, we would also find it as saved as final figure as we specified. That would be all regarding this tutorial. I guess it has been quite a long one. Thank you for following it until the very end. If you have any questions or comments, let me know, and until next time.